Okay, so this video will serve to help you update your Chapter 10 learning log, okay? So we're going to take a little bit of notes, and then I've got some math notes that you're just going to go ahead and tape in, okay? So go ahead and start with this paper first. Here are the learning targets for Chapter 10. You should be able to solve probabilities and determine association in two-way tables. So you should be able to create a two-way table, and then convert it to a two-way frequency table, and then check across the rows for association. You should be able to solve equations with fractions by changing it to an equivalent equation that doesn't have fractions by multiplying by the least common multiple in the denominator. You should be able to solve problems that have square roots, absolute value, or equivalent bases using either rewriting, looking inside, or undoing. You should be able to recognize the number of solutions for a quadratic, either one that's in perfect square form or standard form, or an absolute value equation without even solving it. You should be able to find imaginary roots of a quadratic equation. So you should know that the square root of -1 is equal to I, and how actually now we know that every quadratic can be solved algebraically, just sometimes the roots are not real, they're imaginary. You should be able to take two equations and graph them and find their intersection point and estimate a solution. And then I'm going to have you do one of these too, even though we didn't do it in class. I think you can find the intersection of a line and a quadratic algebraically. So I'll kind of end the video asking you to do one of those and seeing how that works. Okay, so here's a list of some of the vocab in this chapter that you should be aware of. If there's something in here that you don't know, if you go into your online textbook, and all these should be in the glossary, okay? All right, so next page, you're going to write a few notes down. So just paper here. A couple of techniques we talked about doing were how to solve by using a few different techniques. Okay, so how could you solve an equation by undoing? Or let's do rewriting first, sorry. Solve by rewriting. Okay, so if you're solving an equation by rewriting, basically you're going to use some algebraic techniques to rewrite the equation. Okay, often this involves, so usually involves using the distributive property. Okay. All right, so let's take, for instance, say you want to solve x minus 1 squared equals 9. So a technique you could use is to rewrite this. I'm going to go ahead and square x minus 1. Now remember, that means x minus 1 times x minus 1. You could make a generic rectangle to multiply that, or just make sure you get all the parts. You're going to get x squared minus 1x plus 1 equals 9. I'm going to realize it's a quadratic. I'm going to set it equal to 0. Let's see, minus 8 equals 0. Okay, and then I could either use a quadratic formula at this point, or I could try and factor it. Okay, I think I'm going to try and factor it. So it factors into x minus 4 times x, let's see, plus 2. All right, so my two solutions would be x is either equal to 4 or -2. Okay, so rewriting often involves the distributive property. Okay, another technique you could have used would be to solve by looking inside. Okay, so, and then when you're looking inside, basically what you're going to do is you're going to choose part of the equation. That includes the variable and usually is grouped together. by parentheses or another symbol. Okay, use that to rewrite, or to write, I should not say rewrite, to write a new, simpler problem. Oh, geez, there's an I in simpler. Feels wrong, doesn't it? Okay. So let's go back to this same problem right here. So I'm looking inside. Okay. Oh. All right, so I'm going to focus on something squared is equal to 9. So what could I put in there and just solve? So I know that 3 squared is equal to 9. I also know that negative 3 squared is equal to 9. So all I need to do is set that equal to 3 and solve it. So x minus 1 could equal 3. Okay, giving me that one answer, 4. Or x minus 1 could equal negative 3, giving my other answer of negative 2. That's how looking inside would work. Okay, last technique. Oh, I should have written a little smaller. Undoing. Okay, so when you're undoing, you're basically going to start by undoing the last operation that was done to the variable. Then continue to undo by reversing the order of operations. Okay, I think I'm going to just put this problem up here. So I'm going to do that same problem again, but I can solve it by undoing. So x minus 1 squared equals 9. So what's done to x? X is I'm subtracting 1 and then squaring. So I'm going to undo that. So I'm going to start by taking the square root of both sides. So x minus 1 is equal to plus or minus the square root of 9, which is basically 3. And then I'm going to go ahead and add 1 to both sides. So I get x equals 1 plus or minus 3. Okay, so if x is equal to 1 plus or minus 3, x is either going to equal 4 or negative 2. So I solved that same problem 3 different times using 3 different methods. Okay, next, can you put in this paper in your notes? So equivalent equations. Okay, so 2 equations are equivalent at all. Their solutions are the same. There are several ways to change one equation into a different equivalent one. Common ways are to add the same numbers to both sides, subtract the same number from both sides, multiplying on both sides by the same number, or dividing both by the same number. Okay, so just knowing that if you take an equation and multiply on both sides, or add or subtract or divide by the same thing, you're going to get another equivalent equation that's going to give you the same answer. Okay, so I think that's the idea of what you would do if you're going to solve equations with fractions. Okay, all right, so one way of solving an equation that has a bunch of fractions in it, okay, is to maybe hunt for a common denominator that you could just multiply everything by to make it a simpler one. So in this case, I've got 3 and 5, so that like the least common multiple of 3 and 5 is 15. If I multiply each of these terms by 15, okay, it's going to help me come up with maybe an easier equation to solve. Okay, so 5x plus 3 equals 30 might be an easier one to solve. Okay. So the number that you use in the denominator is basically how you're going to bust the fraction. Okay, I want to go over just another one that's maybe a little bit more complicated. Okay, let's say I had x plus 2 over 3 minus 1 or something. Okay, so if I wanted to solve this, I could just multiply the whole equation by what common denominator? Okay, did you think 12? Okay, so when I multiply each of these terms by 12, this 12 and this 3 are basically, I could multiply the top by 12 and then divide it by 3, or I could just simplify the 12 and the 3 to a 4. So basically this is going to be changed to 4x, okay, plus 8. Okay, and then I could cross out the kind of this 12 and this 4. So I could multiply these by 12 and then divide by 4, but basically the net result is going to multiply this thing by 3. So minus 3 times the x plus 4. Okay, and then I'm going to multiply this other side by 12. Okay, so then I basically get 4x plus 8 minus 3x minus 12 equals 12. And then that would be a simpler equation that I could just solve from there. So it looks like I'd get x. Let's see. So minus 4 is equal to 12. It looks like x is then 16. Okay. So which would be easier than dealing with these fractional parts. Okay. So it's one way to deal with solving equations that have fractions in it. Okay. Okay, so next is number of solutions to a quadratic equation. Okay, so what we kind of figured out were two different things. If we have an equation in standard form, okay, that ax squared plus bx plus c equals 0, and we wanted to know how many real solutions it has, okay, thinking real, you could just look at the value under here, okay? If b squared minus 4ac, the value under the root, is a negative number, then that means there are no real solutions, okay? But there would be imaginary numbers, because once you have that negative root, you could change it into something I, okay? If this ends up equaling 0, okay? So the first one, so b squared minus 4ac was a negative. There were no real solutions, no real solutions. If b squared minus 4ac is equal to 0, okay, then basically you're just going to left with this single fraction there. It's going to end up being only one solution, okay? And if b squared minus 4ac is equal to a positive, okay, then there's going to be two solutions, because you'd be subtracting and dividing whatever that positive number, or subtracting and adding whatever that number is to the negative b, okay? The other thing we talked about is predicting how many solutions are, and I know this didn't look like it kind of went up here very well, squared. If you have ax minus b squared equals c, and you want to know how many solutions there are, okay? So if I want to go ahead and take the square root of both sides, if c is a negative number, I'm going to be stuck not having no real solutions, okay? Now, if c is a negative number, then I could take the square root of the negative if I extended to imaginary numbers. If c is 0, okay, so if this value ends up being 0, there's going to be one solution. And if c is a positive number, then when I take the square root, I'm going to get two possible values for x. So there'd be two solutions. Okay. So that's a way to just look at the different types and see how many solutions there are. Okay. If a quadratic equation is in factored form, okay, there's usually going to be two solutions. Okay, unless these two things are the same, then there's only going to be one solution. Okay. All right. Then the last thing, we did talk about the real number system. Okay. So we kind of talked about how if I have, let's say I try and solve x plus, let's see, 3 is equal to 5. Okay. So what kind of answer would I get for that? So that would be 2. What kind of number is 2? That's a natural number. That's sort of our first set of numbers that probably humans worked with. How about if I have x plus 3 is equal to 3? What kind of number would I need for that? Okay, so remember that's a whole number. So the natural numbers like 1, 2, 3, dot, 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 the whole numbers include 0 with those numbers. How about if I had x plus 3 is equal to 2? Well, now I need to extend my number system out even more. I need some negative values. Okay, so that the next bigger set of numbers are the integers. So those include 0, 1, 2, 3, etc., plus their opposites. Okay, so integers. How about if I tried to solve the problem to x is equal to 3? Well, I need another set of numbers because x would have to be 1.5. Okay, those are the rational numbers. Okay, so rational numbers are any number that can be written as a ratio of two integers. So A and B are a ratio. And then we also talked about like, well, what if I had x squared is equal to, say, 2, and I tried to solve that. Well, if I took the square root of both sides, I get x is equal to plus or minus the square root of 2, okay, which is not a number that can be written as a fraction or of a ratio of two integers. So I need to extend the number system even more to the irrational numbers. Okay, so irrational numbers are numbers like the square root of 5, negative square root of 2, pi, e. They have decimals that are non-terminating and non-repeating. Those sets of numbers together make the real numbers. Okay, so that's most of what we've been doing in math. All right, so we talked about, well, let's extend this even further. How about if I tried to solve x squared is equal to -9? Well, if I tried to take the square root of both sides, I'd get x is equal to plus or minus the square root of -9. Okay, well, there are no two real numbers that you can multiply together to give you -9, but there is an imaginary number. So we talked about breaking up the square root of -9 into the square root of 9 times the square root of -1. We can do the square root of 9, that's 3. And then we talked about how mathematicians defined the square root of -1 as being I. Okay, so if I want to try and solve this problem, I actually can, but I have to use a whole nother set of numbers, okay, called the imaginary numbers. Okay, so the complex numbers are the subset of numbers that include the imaginary and real numbers together. Okay, so where they're of the form a plus bi, where this is the imaginary part and that's the real part. Okay. All right. I think that's the end of your notes.